in this lecture I will talk about the OSPF process ID and what does it mean when they say that it is locally significant. So here the topology that we will use in this lecture, where we have three routers, router 1, router 2 and router 3, and we have the network 192.168.1.0/24 and the network 192.168.2.0/24, and we have three loopback interfaces configured on the on each router. Now if we go to router 1 and start configuring the OSPF protocol, and here I will use the OSPF process ID number, let us make it 12, and then we will advertise the networks or enable the protocol on the interface fast Ethernet 0/0, so 192.168.1.1 in area 0, and we have to set the wildcard mask, and then I will configure that also for the loopback 0 interface. Now I will go to router 2 and also start configuring the OSPF, but here I will use a different process ID. Let us make it 21, and then I will advertise the network 192.168.2.1.2, and then the wildcard mask of 4 zeros, and then the area should be area 0, and after that I will also configure the protocol on the loopback 0 interface, so 2.2.2.2. we see that the adjacency came up between router 1 and router 2, so the protocol worked between the two routers, although the two routers has a different process ID. So the process ID on router 1 is 12 and on router 2 it is 21, and although the process ID is different between the two routers, the protocol worked between the two routers. And let us check more using the show IP route OSPF. We see that router 1 received the route of loopback 0 on router 2, and also router 2 received the route for the loopback interface on router 1. So although the process ID is different between the two routers, that does not matter. The thing that that matters is the area ID. The area ID or the area number should be the same between the two routers. So this is the meaning of the OSPF process ID being locally significant. It does not matter if it is different between two routers. Now they say that it is locally significant, so it matters on the routers itself locally, not between two routers. So to understand that, let us go to router 2 and start configuring another process, OSPF process. So router OSPF, let us make it as 23, and then here I will advertise the network 192.168.2.1, which is the network between this router and router 3, and let us make the area the same as area 0, and I will go to router 3 and configure OSPF process. Let us make it as 32, and then I will advertise the network 192.168.2.2, 4 zeros, and then area 0, and also I will advertise the loopback interface, so 3.3.3.3. we should see that the OSPF adjacency came up between the two routers. So let us check using the show IB OSPF interface brief. Okay, we see that the OSPF is now up between router 3 and router 2. It just took some time for that. And let us check now on router 2 if it has the OSPF route. So do show IB OSPF, show IB route OSPF. We see that router 2 received the route of the loopback of router 3. And on router 3, let us use the command show IB route OSPF. We see that it does not have any OSPF routes. And the reason for this is because we have advertised the loopback of router 2 under the OSPF process number 21. And router 2 has an adjacency with router 3, but under the process OSPF process number 23, which is different from the process 21 that the loopback interface and the network 1.0 is advertised in. So this means that the network 1.0 and the network 2.2.2.0, the network of the loopback, are under the OSPF process number 21, and the adjacency between the two routers is under the process 23. So this is like using two different routing protocol on router 2. So anything that is in this process, OSPF process, will not be advertised or sent to the other routers on the other process. We have to configure redistribution in order for the two process IDs on the same router to move routes between the two routers. So also on router 1, if we check using the show IB OSPF show IB route OSPF, we see that it has the loopback of router 2, but it does not have the network 2.0 or the loopback of router 3, because as we said that it is like configuring two different routing protocols on router 2, and any information on this routing protocol will not move to the other routing protocol and vice versa. So in order for us to move the routes between the two process IDs, we have to configure redistribution. And this is, as we said, the reason that they said that the OSPF process ID is locally significant. So it matters on the router, as we saw that when we have two different process IDs, then it has an effect by separating the routes between the two OSPF processes, but between two different routers it does not matter. So let us configure redistribute or redistribution. So here I will redistribute the process or OSPF process number 12 subnets to the 23 and then I will go to the process number 12 itself, and I will redistribute the process number 23. Sorry, the process number here is not 12, it is 21, so I have to redistribute the 23, and then under the 23 I have to redistribute the 21. Now if you go to router 1 and check for the routes, now we see the external routes coming from the other process, which is the loopback of router 3 and the network between router 2 and router 3. And also on router 3 we should see routes coming from the other process, which is the loopback of router 1, the loopback of router 2, and also the network between router 2 and router 3. So now we can understand the meaning of OSPF process ID and the meaning of when they say that it is locally significant. But why, or what is the design case where we should configure two different process IDs on the same router? The reason for this is that we want to separate communication or routes moving between two parts of the network. So we do not want to advertise all the routes from this part to this part and vice versa. So we will configure two different process IDs on the same router, and then when we configure redistribution on the router, we can add route map or conditional. We should make the redistribution conditional, so that only some routes on this part will be advertised to this part, and also vice versa. So we can or we should have, or we will use a control or controlled redistribution between the two parts in order to get the purpose of configuring two different process IDs on the same router.